looking at number 3. What again we're looking at here is what situation? What's going on here? So we got water going into the tub. Are we all listening? Yeah. Okay, calculators are down right now. We're going to follow this one together, okay? We're talking about the number of minutes and the amount of water that's going into the tub, and there's no question here. So we're doing this together. What is the rate of change that's happening in this table? How do you figure out rate of change? Divide what? Divide y by x. So up here we've got, somewhere on your paper, write change of y over change of x. And so we're trying to figure out, in this table, does it have a constant rate of change? And if it does, what is that constant rate of change? Change of y. Which one of these is our y? The gallons, right? So if I'm looking here, how much is my y changing by from 6 to 9.6? Okay, so draw that arrow and write 3.6. And it's adding 3.6, so I put plus 3.6. This is going up by plus 3.6 over, how much is the change of x changing by? By plus 3, right? Okay, so if I'm going to find that as the unit rate, what am I going to do? What do I do with 3.6 over 3? Divide it, and what do you get? So I'm going to divide it, and I get 1.2 what? 1.2 gallons for every what? 1 minute. Okay? So I had somebody tell me this doesn't have a constant rate of change because let's look what happens next. What's this going up by, Garrett? Okay, so he says it's going up by 2.4. So if I were to draw this again, change of y over change of x, I get 2.4. But this time, how many minutes went by when it was measured? How many minutes? 2. So if I simplify that out, 2.4 divided by 2, what do we get? What do we get? 1.2 what? For every what? Every 1 minute. Is this a constant rate of change? Did it just get scaled up by the number of minutes here? Yes. And so doing that again, William, can you walk us through this one? What did we do here to find out what our difference is here? 12 to get to 16.8.
Well, well, you just you add whatever 16 is, like, whatever 16.8 minus 12 is.
And what is that, guys? Help them out.
I don't know.
Plus 4.8. Plus 4.8, so I've got 4.8 for every how many minutes? For every 4 minutes. If I simplify that down, what am I going to get? If I divided that 4.8 divided by 4, I get 1.2 gallons every 1 minute. Okay, and stopping you guys. I want you to see how important it is for you to write out your variables. 1.2 gallons every 1 minute is very different than 1.2 minutes every gallon. Okay? So if you just have numbers, it's not working. Okay? I'm almost done. Asa, you with me? Can you tell me about this number? Is this number important right here? Look where I'm. Tell me about this number. What is this describing in the situation? In when?
0.
In 0 minutes. So before I did what? Before what happened? Before we turned the water on, there was already 6 gallons. How many of you right now can make an equation? There's enough information here to make an equation. Anybody can do that? Anybody? All right, so we're going to put it together. We've got y So I'm going to write it over here. I've got y equals, how much did I start with? So I have 6 already. I have 6. And I need to add how much I'm getting per minute. I'm going to add 1.2 times, if x is standing for minutes, times the number of minutes that the water's been running. Okay? If I were to check this for this coordinate pair right here, what am I putting in? Where does the 5 go into this equation? To check to see if my equation's correct. Goes into x for minutes, so it becomes 6 plus 1.2 times what number? Times 5. And if I calculated that, what am I going to get? I'm going to get 12. Okay? So that coordinate pair is showing up right there and there. Who's got that? Did you guys write that down? Is it linear? Yes. What makes this linear? There's one special thing that makes this linear. Gates? It has a constant rate of change. Alondra, did you hear that? It all has a constant rate of change. So when your next question asks if it's linear or not, what are you going to be looking to see? If it all does what? Has a constant rate of change. Okay? You guys good? All right, and keep working. 10 minutes.